Mean of a group data could be calculated using three different methods: the direct method, the assumed mean method, and the step-deviation method. Let's begin by calculating mean using the direct method. In the sugar factory, sugar bags are separated on the basis of their weight. The table here represents this distribution. Mean weight of the sugar bags could be found by dividing the sum of the product of Fi and Xi by the sum of Fi. Here, Fi is the frequency of the given class, and Xi is the class mark of that class. It is assumed that the frequency of each class interval is centered around the midpoint for that class. This midpoint is called the class mark. The class mark represents the observations falling in that class. Since the class mark is the midpoint of the class interval, adding the upper and the lower limits of each class and then dividing the sum by 2 will give us the class mark for that class. Click on the sugar bag in the class mark column to view the class mark for each class interval. Now that we know the value of the class mark for each class, let's calculate the product of Fi and Xi. Click on the sugar bag in the Fi-Xi column to view each of these products. Now, click on the sugar bag next to summation of Fi-Xi to view the sum of the products. Substituting the values in the formula, we get the required mean. Mean could be calculated using the direct method, but sometimes the frequency, Fi, and the class mark, Xi, are large numbers, and the calculations using direct method becomes lengthy and tedious. In this case, we use the assumed means method to calculate the mean. In the assumed mean method, our first step is to choose an assumed mean A among the Xi values. For the purpose of simplifying our calculations, we usually pick the assumed mean to be the number that lies in the middle of the Xi values in our data. We then calculate deviation, di, by subtracting A from each class mark. Click on the sugar bag in the di column to view the deviation for each class interval. Now, click on the sugar bag in the Fi-Di column to view the product of the frequency Fi and the deviation, di. Clicking on the sugar bag next to summation of Fi-Di will give us the sum of the products of Fi and Di. Now that we have the sum of the product of frequencies and the deviations as well as the sum of the frequencies, we can calculate the mean deviation by dividing the two. To calculate the mean, we must add the mean of deviations to the assumed mean. Click on the formula to see how this formula is derived. Substituting the values for assumed mean and mean of deviations, we get the required mean, which is equal to 54. Now look at calculating mean using step-deviation method. The step-deviation method simplifies the values of di further, so that we get even smaller values for the product of the frequencies, Fi, and the deviations, di, than we got in the assumed mean method. Notice that the class size H for the given data set is 20. To further simplify our calculations, we take the deviations di and divide it by the class size H. Click on the sugar bag in the UI column to view corresponding values. The next step is to multiply the frequencies with their respective UI values. Click on the sugar bag in the FI UI column to see the values of the product of each frequency and UI. You can now click on the sugar bag next to the summation of FI UI to obtain the sum of the product of FI and UI. The mean of UI can be calculated by dividing the sum of the products of FI and UI by the sum of FIs. Mean can be calculated using the formula A plus H times mean of UI values, where A is the assumed mean and H is the class size. You can click on the formula to see how it is derived.